Okay. Okay. What we discussed last week, Friday, we discussed up to carbohydrate with all experiment. Practically, I explained how we doing Benedict test for non-reducing sugar, as well as how we doing Benedict test for non-reducing sugar. Okay. The first question, in non-reducing sugar identification test, what is the purpose of adding HCl? I have HCl done. Send your answers. What's the purpose of adding HCl or whatever powerful acid for non-reducing sugar identification test? The final experiment we did. Okay, send your answers. Answers, Dihini? Yes. To hydrolyze or break down non-reducing sugar, that means complex sugar, into simple form. Its simplest form, the simplest form is reducing sugars. Simplest forms are reducing sugars. Next one. Next question. Why we need to add sodium hydroxide or whatever, sodium carbonate or whatever powerful base? Sodium carbonate or sodium hydroxide, what's the purpose? Kabir, what's the purpose of adding sodium carbonate or sodium hydroxide, sodium hydroxide like base compound before Benedict test? To what? Dihini? For what? Tanya? Yes, good. For neutralize the solution. Why we need to neutralize? What is the requirement? I have neutralize karaganda. Why? Why? Okay, in HCl and it's at HCl and heating, then we can break down and convert non-reducing sugar into reducing sugar. That means complex carbohydrate into simplest form. Okay, then already hydrolysis. Now after hydrolysis, why we need to, by adding sodium hydroxide, why we need to hydrolyze, neutralize it? Why? Yes, the Benedict and Felix, they only react in neutral conditions. They not react in highly acidic or base conditions. They only work 6.5 to 7.5 range. Okay, that's why we need to add sodium hydroxide for neutralizing. Okay, they are the key points, key question points. Okay, let's move into then carbohydrate completed. I'm going to move into our second organic compound, proteins. Okay, this lesson, as I told earlier, we mainly discussing about organic compounds. Organic compounds. I think you can remember. Compounds mainly two types: organic compound and inorganic compounds. Inorganic compound mean carbon hydrogen bond absent. Absent carbon hydrogen bond. That means carbon absent as well as carbon hydrogen bond absent compound we called as inorganic compounds. Organic compounds mean compounds with carbon and hydrogen bonds. Okay, the first organic compound we already completed. That is carbohydrate. Okay, this is our second organic compound. It is proteins. 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 Second one. Proteins. Proteins. Okay, protein is an essential compound in living cells. I told carbon, the main characteristic of carbohydrate, they only contain carbon, hydrogen, and oxygen, right? But the main characteristic of protein, they only contain carbon, hydrogen, oxygen plus additionally nitrogen. Remember, carbon, hydrogen, oxygen plus additionally hydrogen. Additionally hydrogen and phosphor and sulfur, very rare molecules. They are very rarely available. I will explain what are the types: phosphorus and sulfur. Sometimes sulfur also possible to available as a molecule, but it is not compulsory. It's not compulsory. They main molecules are in carbohydrate, carbon, hydrogen, oxygen only. But in proteins, carbon, hydrogen, oxygen plus nitrogen as well. Carbon, hydrogen, oxygen plus nitrogen. Carbon, hydrogen, oxygen, nitrogen. Okay, they are the main molecules important make proteins. Carbon, hydrogen, oxygen, nitrogen. Sometimes sulfur can be also be present. Okay. Okay, they are very simple things. Okay, tell me, proteins contain foods. Tell me example. What are the foods contain proteins? Milk, very good. Milk, very good. Yes. Milk, good. What else? Let's start very, yes, very good. Meat protein sources, right? Meat, what else? That's only? Is that all? Yes, eggs, very good. Eggs, fish and meat both same. Yes, nuts. Soybeans, right? Soybeans. What else? Okay, nuts. Let's take nuts later. Okay, I want to explain. If you got the protein of milk, the main protein type of milk we called as, what do you think? What's the main protein type of milk? What is the main protein type of milk that we called as casein? Casein. Casein. If you got meat, It is myoglobin. Myoglobin. Eggs. Eggs are the protein. What's the proteins of eggs? The white yolk of the egg that we call as albumin. 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 Okay, now you can understand if you got our blood, the protein we called as hemoglobin. Hemoglobin. Okay, now you can understand different food sources, different organic compound, different types of proteins are there. Different types of proteins are there. Okay, different types. See, different names. Different names. When change the biological structure, biological source, their names, characteristic, their structures, everything identical to identical. Different to one different. That means they are identical. Identical. The casein structure is identical. Myoglobin, it's another structure. Albumin, difference. Myoglobin difference. Okay. Commonly, there are the different types of proteins. Okay. 17% of mature human body is composed of proteins. Protein is a complex molecule made up of polymerization of. Do you remember what is the main building block of carbohydrate? Amina, what's the main building block of carbohydrate? Carbohydrate main building block? The very simplest compound? I need answers. Main building block is very good, monosaccharide. Monosaccharide. Remember, the protein main building block we called as amino acid. The amino acid is the main building block of proteins. Okay. Meat, fish, eggs, egg white. Egg white mean white yolk. Cereals means soya beans, like some of foods rich in protein, rich with protein. That there are different protein types and there are different structures we can discuss in the mid of the lesson. Okay. Now I told the main building block of the protein we called as the amino acid. The amino acid is the simplest compound. That's in our body, the simplest compound is cell, right? In carbohydrate, the main building block is monosaccharide. In proteins, the main building blocks, the simplest compound we called as a amino acid. It is amino acid. Okay, what is the structure of amino acid? It is very simple. The middle, there is a carbon that we call as alpha carbon. This is the middle carbon. And it has group, special functional group that we call as COO. This group we called as carboxylic group. Very important. This is alpha carbon combined with carboxylic group. And alpha carbon combined with carboxylic group. And there is another group that we called as NH2 group. Very simple. The middle carbon, this is alpha carbon combined with COOH. COOH means carboxylic group and amine group. Metana tiyenne meyage hydrogen bond. This is the R carbon chain. Okay, this is the common structure of amino acid. common structure of amino acid. Common structure of amino acid. Okay, this part we called as carboxylic group. Carboxylic functional group that we called as amine group. Amine group. This is a hydrogen. This is hydrogen, and that is important. This is the R carbon chain. R carbon chain. Okay, this is a common structure. Common structure. This carboxylic group, amine group, hydrogen, they are compulsory. They are not changing. But in amino acid, according to the type of amino acid, this R carbon chain is different. This R carbon chain is different. Due to the variation of this R carbon chain, we call different name for this different structures of amino acid. I will explain all amino acid structures. You want to remember few points of each amino acid, then you can understand what's the meaning of the amino acid and how form proteins by amino acids. Okay, that's our target. No? Our target not only understand amino acid, our target how to form proteins from this amino acid. Okay. Okay, then what is the common structure? This is alpha carbon, carboxylic group and amine group and hydrogen bond, and R carbon group. According to the variation of R carbon group, different types of enzymes are formed. So not enzymes, amino acids are formed. Okay, the same structure we can draw in another version. The COOH we can write COOH. In simple form, we can write COOH. COH. NH2, we can write this way. NH2, amine group, hydrogen, and R carbon group. Okay, that is a common structure of the amino acid. Common structure of the amino acid. Common structure of amino acid. Okay, amino acid have both amine group. Amine. Make it E kara. Amine. And carboxyl. COOH. Carboxyl COOH. Amine means NH2, correct. Functional groups. The amino acids are classified as and so based on the relative position of the amino group with respect to the carboxylic group. Carboxyl group. When proteins are hydrolyzed, only amino acids are produced. Yes, they are the building blocks. If proteins hydrolyze, again converted to amino acid. Okay. They may also contain other functional groups. Okay, I will explain later. Okay. Okay, this is the common structure of amino acid. This is alpha carbon, carboxylic group, amine group, hydrogen, and R carbon group. Hydrogen bond and R carbon group. R carbon chain. Okay. This hydrogen bond and R carbon chain. R carbon chain. R carbon chain. Okay, up to now clear? This is the common structure of amino acid. common structure of amino acid. Amino acid are the building blocks of proteins. Proteins are amino acid වලින්. Okay, send me message up to now clear. Okay, now I told this carboxylic group, amine group, hydrogen group, they always compulsory. Every amino acid contain this common functional group. They are common. They are compulsory. But this R carbon chain, R carbon amino acid to amino acid, this R carbon chain is vary. They are changing. Okay, let's see different types of amino acid for understand. Okay, if you got, there is a very simple amino acid that we called as glycine. Okay, glycine, glycine, glycine. So CIN, glycine, glycine, glycine. Okay, this is the structure of glycine. This is alpha carbon, COOH. What is this? Carboxylic group, amine group, NH2, hydrogen. This is the R carbon chain. R carbon chain replaced by another hydrogen. That's why we call as, that is the simplest amino acid in the world. That's the simplest amino acid in the world because it don't have R carbon chain. R is replaced by another hydrogen. Okay, this is the simple structure of glycine. Simple structure of glycine. It is very simple R carbon chain. It has very simple R carbon chain. This is the glycine. Okay, if you got another amino acid, if you got cysteine, 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 this is alpha carbon, COOH, මේවා common. They are compulsory. COOH functional groups, NH2 functional group, hydrogen, and R carbon chain is changing. Okay, amino acid to amino acid, R carbon chain is changing. Okay, the cysteine R carbon chain is replaced by CH2 SH, CH2SH. Okay, can you understand the, can you find any specialty of cysteine than other amino acids? What's the specialty of the cysteine? Specialty what? Yeah, glycine is special because they have very simple R carbon chain. Why cysteine is special? Any idea? Any idea? Yes, Kabir, correct. Rehlan, what do you think? Why it is important? Yes, it contains sulfur. It contains sulfur. That is the one and only amino acid contains sulfur in the world. That's a only amino acid contains sulfur. Only amino acid contains sulfur. Only amino acid contains sulfur. This is the one and only amino acid. Okay, cysteine. Cysteine. Okay, go to the page number 15. Page number 15. R represent a group of R group containing both carbon and hydrogen. Yes, it is carbon hydrogen group chain and hydrogen. Yes, carbon and hydrogen. Due to the change in R group, 20 different amino acids. Yes, important. Okay, I told the common structure of amino acid is alpha carbon, carboxylic group, amine group, and hydrogen bond and hydrogen group and R carbon chain. This every amino acid, this amino group, sorry, carboxylic group, amine group, and hydrogen group is same. They are මේවා හැම එකේම තියෙනවා. They are common. But R carbon chain is amino acid to amino acid. This R carbon chain is vary. Understood? Okay. Now, according to the change of this R carbon chain, 20 different amino acids we can identify. They are involved for protein production. 20 different amino acids involving for protein production. Protein production. All proteins present in organism from bacteria to human are made up of these 20 different amino acids. All proteins are made up with this 20 different amino acids combined in different sequences. Okay, the sequences, what's the meaning of sequences? I will explain in our protein part. Okay. The simplest amino acid in the world is glycine. Yes, glycine. The simplest amino acid in the world. It has carb. This is make a turn on. Don't think about this turning. Okay, the same thing. It has amine group, carboxylic group, hydrogen. They are compulsory. Then R carbon chain again hydrogen. Okay, don't think about මේවා change වෙන්න පුළුවන්, but the other amine group, carboxylic group, alpha carbon, hydrogen, in R carbon chain is again hydrogen. Okay. 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 Classification of amino acid we can discuss later. This classification we can discuss after discussing amino acid. Okay, amino acid we can divide into two main categories. Two main categories. Amino acid. Okay, before that, let's discuss about amino acid. No? Go to page number 16 in the tute. Go to page number 16. Different types of amino acids. Okay, the first one is glycine. Draw the structure of glycine in the front box. The second one is cysteine. Draw the structure of cysteine in front box. Complete. Okay, the third one, alanine. Alanine, alpha carbon, COOH, carboxylic group, amine group, NH2, hydrogen one, CH3 is the R carbon group. This is alanine. Third one, alanine, right? Alanine. 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 Quickly draw this. Fourth one, glutamic acid. Glutamic acid. Glutamic acid. Alpha carbon, COOH, carboxylic group, NH2 amine group, hydrogen one. Hydrogen one. Give me a second. Glutamic acid. Remember the R carbon chain of glutamic acid. It is CH2, CH2, COOH, CH2, CH2, COOH, CH2, CH2, COOH. CH2, CH2, COOH. Can I erase? You complete, send message. Okay. Next one, lysine. Lysine. Can I erase those? Rehlan, complete. Okay, I will do this side. Next one, lysine. Lysine. Alpha carbon, COOH, NH2, hydrogen. They are common. Okay. Carboxylic amine and hydrogen. Okay. The lysine R carbon chain is a long R carbon chain. Therefore, I will write from this point CH2, 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 NH2. CH2, 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 NH2. Sorry, CH2, 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 4CH2 and NH2. Amine. Final one NH2. Okay, let's move into valine. Valine, alpha carbon, COOH, carboxylic group, NH2 amine group, hydrogen. The R carbon chain is a long one. I will write in simple way. Yes. CH, CH3, CH3. CH, CH3, CH3. Okay, now you can understand the carboxylic group, amine group, hydrogen, they are common. See? Only R carbon chain is vary. Okay. Complete? Complete? Not yet. Okay. Dihini? Amina? Done. Good. Okay, final one isoleucine. Isoleucine කියලා කියවන්නේ. Isoleucine. 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 Alpha carbon, carboxylic group COOH, amine group NH2, hydrogen. It's bit complex. Okay, C, hydrogen, CH2, so this is CH3, CH2, CH3, bit complex. Okay, this part R carbon chain. Okay, this is R carbon chain, bit complex R carbon chain. This is R. Are you done? Dihini? Fatima? Complete? Okay, they are not all amino acid. Okay, how many amino acid we discussed? 1, 2. We discussed glycine. That's a world's simplest amino acid. Cysteine, one and only amino acid, contains sulfur. 1, 2, 3, 4, 5, 6, 7 only we discussed, but we have 20 different amino acid important to produce proteins. But we don't need to remember everything. 20 you have to remember. 20 amino acid involved for produce proteins. Okay, 20. Okay, this 20 amino acid, we can classify it into two main categories. We can classify it into two main categories. The first one is essential amino acid. Essential amino acid. Non-essential amino acid. Non-essential amino acid. This 20 amino acid, we can classify it into two main categories: essential amino acid and non-essential amino acid. Okay, what is the meaning of essential amino acid? Essential amino acid mean amino acid we cannot produce in our body. We can't produce in our body. Okay, we have to get this amino acid as a food source. Meat selling, eggs, milk, we have to get externally. Non-essential mean they can make in our body, in our biological structure. They can generate. Okay, therefore they are not compulsory to take by foods. But essential amino acid we can't make in our body, in our structures, biological structures. We need to get externally as a food sources. That's the difference. Okay, in the TUT page number 16, before different types of amino acid topic එකට කලින් දීලා දෙනවා මම. Out of 20 amino acid, 9 as an amino acids are essential. 9 amino acids are essential. That means among these 20, 9 essential. 9 amino acid we can't produce in our body, living structures. But 11 amino acids, okay, no problem. We can make in our body. They are different, identified as essential because they cannot be produced within the human body. Complete? Understood? They cannot be produced in our body. They are histidine, they are the essential histidine, leucine, histidine, everything given in the table with highlighted histidine, leucine, 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 isoleucine, this one, isoleucine, methionine, 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 and threonine, threonine, phenylalanine, tryptophan, valine, and lysine. Okay, they are the 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, all essential amino acids are given. Essential amino acid important. They can't produce in our human body. Non-essential mean they can produce in human body. They are not essential. Okay, this is a one classification. Again, we can classify these amino acid in the first part of the 16, page number 16, first part I have given amino acid. We can classify it amino acid. Again, we can classify it into three main categories. Three main categories. Acidic amino acid. If it is name given amino acid, all amino acid not acidic. pH value not less than 7. Acidic. Again, we can acidic and base amino acid, and neutral amino acid. Neutral amino acid. Neutral amino acids. Mainly three types: acidic amino acid, neutral amino acids, and base amino acids. Okay, acidic mean all neutral base, neutral acidic or base depend on the R carbon chain. Always depend on R carbon chain. The meaning, R carbon chain present, R carbon chain present, COOH group, R carbon chain. Okay, understand. Every monosaccharide present R carboxylic group in the combined with alpha carbon. But in R carbon chain COOH carboxylic group present, that we called as acidic amino acid. Okay. Go to I give an example in this page. Okay. Name one acidic amino acid. Acidic amino acid. Who are the acidic? Yes, glutamic acid. Yeah, the name also given. It is acidic. Yes, glutamic acid is acidic. Glutamic acid. Glutamic acid. Glutamic acid. Glutamic acid is a acidic amino acid. Acidic amino acid. Acidic amino acid. Okay, base mean in R carbon chain, R carbon chain, any amino acid R carbon chain present NH2 group. NH2 group we called as base. Okay, send me example. Previous structures, send me example. Basic amino acid. Base characteristics showing amino acid. Lysine, just see lysine hand with it. Yes, lysine. CH2, 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 CL2, finally NH2. It is a amide group. Only need to consider about R group. They all have amine group in alpha carbon. That doesn't matter. In R carbon chain, if there are any amine group, that additional one, okay, additional amine group that we called as base one, then lysine is lysine example for lysine lysine example for basic amino acid. Okay, then what are the meaning of neutral? Neutral mean other all amino acids are neutral. The reason if in R carbon chain don't have any carboxylic group or amine group, we called as neutral. Then other all are neutral because glycine, cysteine, they don't have carboxylic group or amine group in the R carbon chain. They all are neutral amino acids. Neutral amino acids. Neutral amino acids. Okay, read the relative number of amino acid. So the relative number of amine and carboxyl group in amino acid in an amino acid molecule determine whether it is basic, acid, or neutral. Yes. Okay, let's draw this chart. Let's draw this chart in the given space. In the given space, let's draw this chart. Amino acids. Okay. R carbon chain present COOH group. R carbon chain present NH2 group. No neutral, no NH2O COOH group in R carbon chain. In R carbon chain. Okay, very enough. If you want, you can write example. Write down this is glutamic acid, acidic, lysine, basic, and few example for neutral. Cysteine, glycine. Okay. Complete. Complete. Okay. Amino acid completed. Any doubt? Any doubts up to now? Any doubt up to now? Okay. Everything clear up to now? Okay, good. Let's move into structures of proteins. Okay, I'm going to explain how to make proteins by these amino acids. It's a very interesting part. Okay, now do you remember one monosaccharide? One monosaccharide. The monosaccharide is the main building block of carbohydrate, right? Monosaccharide, one monosaccharide, it's very simple structure, no? Then two monosaccharides combine with glycosidic bond. What is the name? Two monosaccharides combine with glycosidic bond. What is this structure? Two monosaccharide, not proteins, in carbohydrate. Two monosaccharide combine with glycosidic bond. What is this name? Amina? What's the name of this structure? Two monosaccharides combine with glycosidic bond. No, I'm asking carbohydrate, two monosaccharide combined with glycosidic bond. What is this structure? Monosaccharide, previous part. One monosaccharide combined with other monosaccharide with glycosidic bond. එතකොට මේක මොකක්ද කියන්නේ? That is a what is this? Disaccharide, right? This is disaccharide. Understood? It is a disaccharide. One monosaccharide combined with other monosaccharide by glycosidic bond. That we called as disaccharide. Di mean two. Disaccharide. Okay, think three monosaccharide combined with glycosidic bond. What is this? That we call as trisaccharide. Okay, three saccharides, three monosaccharide, trisaccharides. Four monosaccharide combined with glycosidic bond. Oligosaccharide. Hatarak. Four. Oligosaccharides. More than like a chain, more that we called as polysaccharides. Polysaccharide. Okay, the same thing in proteins also, the same thing. Proteins mean, remember, proteins are many number of amino acids. See, they are the amino acid, many number of amino acid combined with peptide bond. Now it's a new bond type that we call as peptide bond. The the peptide bond proteins are polymerization. Amino acid make as a polymer, like a chain, complex structure that we called as a protein. The peptide bond proteins are polymers of amino acid that are linked together by peptide bonds or peptide linkage. Yes. Peptide linkage is chemically defined as an amide formed between carboxylic group and amine group. I will explain what is this amide form. Okay. I'm going to explain about peptide bond. Clearly understand. Okay. Very simple. Do you remember what's the meaning of glycosidic bond? Glycosidic bond means two monosaccharide, between two monosaccharide. What is the main characteristic? What is removing part in glycosidic bond? Fatima? Which molecule is removing in glycosidic bond? Which molecule is removing? Yes, water molecule. H2O molecule is removing in the formation of glycosidic bond. The peptide bond also same. Okay, understand clearly. Clearly understand. If any doubt, please ask. Okay, I'm going to explain how to make a peptide bond between two amino acids. In previous carbohydrate parts, monosaccharide combined with bond, the bond name is glycosidic bond. In this case, amino acid make bond with peptide bond. The bond type is peptide, okay, not glycosidic. In proteins between amino acid, the bond is called as peptide bond. Okay, peptide bond. Okay, okay, this is a peptide bond. This is amino acid. This is a any amino acid, no problem, any amino acid. This is another amino acid. Oh, sir. Okay, understand. This is one amino acid. This is another amino acid. Common structures. Now what happened? These two carboxylic group, OH group and amine group, hydrogen group combine each other. Then this part removing as water molecule. H2O they are removing with water molecule. Okay, now this is the new structure. Others are same. Okay, this is the structure. This bond we called as peptide bond. Removing between two amino acid, the bond between two amino acid by removing one water molecule we called as peptide bond. Peptide bond. Okay, now what is the name of this? Two amino acid combined. What's the name? Two amino acid in carbohydrate, it is disaccharide. In this case, two amino acid, what's the name? The name we called as dipeptide. Dipeptide. This is two amino acid combined with like peptide bond that we called as dipeptide. Dipeptide. The name of this is dipeptide. Any doubt? Dipeptide. Any doubt? Dini, understood? Fatima, understood? Okay. Draw this clearly. Draw with understand. Okay? Don't keep anything for doing later. Everything complete now. Complete. Okay, today I hope to complete whole part of proteins. The next week we can discuss we have one of the paper program also. Next week mean coming Tuesday. Tuesday we can discuss our paper first and complete enzymes. Enzymes also very important part. Today let's try to complete at least proteins with protein structures. After complete proteins, we have enzymes. We have enzymes, lipids, and vitamin. Only 3 parts. In our new syllabus, we don't have to learn about the nucleic acid. DNA, RNA, we don't need to learn. That has removed in new syllabus. Okay, are you done? Complete, right? Dihini? Complete? Okay. Okay. Now, if I ask, is that protein or not? What do you think? Now, both there is MCQ point. MCQ point, A point, point A. Dipeptide is a type of protein. Correct or wrong? What do you think? Kabir, what do you think? Dihini? Okay. B point. Yes, it is wrong. Disaccharide is a type of carbohydrate. Correct or wrong? Yes, very good. Carbohydrates, it's not problem. Monosaccharide, disaccharide, polysaccharides, all are types of carbohydrates. But in proteins, amino acid or dipeptide or tripeptide or oligopeptide, no proteins. Okay, always only polypeptide chain. Normally, what I told now, amino acid. That means simplest building blocks. Amino acids. Amino acid means simplest building blocks. Amino acid. Or dipeptide. Dipeptide means two amino acid combined by peptide bond and make structure we called as dipeptide. Dipeptide. Tripeptide or oligopeptide. More than that, they are not proteins. They are not proteins. They only amino acid structures only. They are not proteins. Remember. Then what are the proteins? Proteins are polypeptide chains only. Polypeptide chains only. Proteins are polypeptide chains only. Polypeptide chains only. Okay. Now, what do you think? කොච්චරකට වඩා වැඩි වුණොත් the proteins වෙන්නේ? How at least how many amino acids should have for polypeptide chain? For proteins. Remember, the limit is 100. At least 100 amino acids should have in the polypeptide chain for consider as a protein. At least 100. Remember this. At least 100 amino acids required for consider as polypeptide chain. Polypeptide chains are the proteins. Polypeptide chains are the protein. Understood? Yes, correct. Okay. Okay, the reaction between two molecules of similar or different amino acid, any type of amino acid, is initiated by the combination of one molecule's amino group with other amino acid carboxylic group that we discussed. One amino acid carboxylic group and second amino acid amine group combine as a linkage, that is the peptide bond. This is caused the removal of one water molecule. Yes, I explained. And the formation of peptide bond. Formation of peptide bond. Yes. Okay. Now, very important part. Most important part. Okay. Any doubt up to now? Or do we have our syllabus? Now, you can check our every points given in the syllabus we need to discuss. If not, you can't face confidently exam. Okay, if not, you can download our syllabus. Syllabus means teacher's guide. Yeah, this is our teacher's guide. You can't see me. Wait. Every points you want to know given in the teacher's guide. If you don't know any point given in the teacher's guide, it's a doubt. It's a problem in exam. Okay. Okay. Let's see about proteins, what they have mentioned. Okay, carboxylic group, amine group, and alpha carbon. First of all, you should have ability to identify them. This is R. Don't think about the side. Don't think. This is carboxylic group, amine group, alpha carbon, and hydrogen, and R carbon group. They given their structures: glycine, alanine, valine, isoleucine, already discussed. එයාලා කියනවා 20 amino acids. See, normally protein production of protein involving 20 amino acid. සැදෙන polymers. See, amino amla කියන කොඩා එකක එකතු වෙලා හැදෙන polymers only we called as proteins. Make a kill then. This next point I will explain later in the structures. Yes, among 29 amino acids, what are them? They are essential amino acid. Atyashika essential amino acid. The list of essential amino acid given in the teacher's guide. Your tute also they are available. Okay, this is the structure we draw now. This is a peptide. After that we called as dipeptide. Dipeptide or tripeptide or simple structures we not called as protein. Only polypeptide chain more than see make a puruk gane can amino amla gana at least 100 vendoni for consider as protein. What else? Then they given about structures. No, next part. Okay, everything we have discussed in your now every point you can understand, right? Okay. Okay, each lesson point by point, very easy to understand. The problem, we don't have English version. Point by point, you every point explaining things you must know. An exam question based on this. Okay. Structures, no? Structures of proteins. Structures of protein. Structures of protein. Oh, sorry. Wait. Okay. Structures of protein. Protein structures we can divide into main 4 categories. The first one, primary structure. Primary structure. Second one, secondary structure. Tertiary structure. Tertiary means third. Tertiary structure. Structure. Final one, quaternary structure. Quaternary structure. Quaternary structure. Okay, they are the main structures of proteins. Okay, understand. I will explain one by one what are the primary structure, secondary structure, very simple way. Try to get your full understand. Therefore, if you got full idea, don't need to again work on this. It's very simple part. Okay. Primary structure. Primary structure. Protein primary structure. Okay, what do you think? Protein primary structure, it is very simple. The amino acid sequence, amino acid order, sequence, we called as a primary structure. This is the primary structure. Think I told 20 different amino acids. No? I think one protein is made glycine, lysine, isoleucine, histidine, again glycine, lysine, isoleucine, histidine, glycine, lysine, isoleucine, histidine. Think this is the amino acid sequence in the polypeptide chain, amino acid sequence. Think there is another amino acid, same 4 amino acids, lysine, glycine, histidine, isoleucine. Lysine, glycine, histidine, isoleucine. Lysine, glycine, histidine, isoleucine. Okay, what you can say is that two proteins are same or different? Is it same or different? Yes, their characteristics are all completely different. Why? Their amino acid order is different. Amino acid order is different. Therefore, in the protein polypeptide chain, the polypeptide chain involved for production of protein, the order of amino acid we called as the primary structure. The primary structure means the amino acid order in the polypeptide chain. Understood? Amino acid order, simply the amino acid sequence we called as the amino acid sequence in the polypeptide chain we called as the primary structure, the amino acid sequence in the polypeptide chain. Okay. One or more polypeptide chains can be found in proteins. Yes. Each polypeptide chain in protein contains amino acid that are linked together in a specific sequence. Specific sequence. Specific sequence. This is specific sequence we called as. එයාලගේ තියෙන order එක තමයි the primary structure. The primary structure. And this sequence of amino acid is referred to the protein's primary structure. The same thing. The second point. The second point. This point also important. Any change in this primary structure, all characteristics and protein type also changing. Therefore, it's not changed to primary structure. Primary structure means amino acid sequence. Amino acid sequence. If you got primary structure, even denaturation, do you know what's the meaning of protein denaturation? Protein denaturation? Do you know? Proteins denaturation? Proteins denaturation means completely change the physical state of proteins. As example, do you know? Albumin is the main protein in egg white. In normal condition, what is it? Is it solid, liquid or gas? It's a liquid, like it's a thick liquid. Albumin. This albumin, if we heat it, then what happens? It is converted into solid. Yes, it's converted into solid. Then if we cooled again, if we cooled in refrigerator, is it converted into liquid again? Yes or no? I am a liquid or not? Is it converted into liquid again? No. Again, not converted into liquid. This is the permanently change the physical states of protein that we call as protein denaturation. Okay, even denaturation condition, even in denaturation condition, this adverse condition, high temperature condition cannot be changed the primary structure. That means sequence එක damage කරන්න බෑ. We can't damage this sequence. Okay, even denaturation cannot change the primary structure. Primary structure cannot be changed even denaturate state. Denaturation means high temperature conditions cannot be damaged to this primary sequence. Okay, the final point, in primary structure only peptide bonds present only peptide bond present in the polypeptide chain. Okay, please note down these 2 points. This point and this. Even denaturation cannot be changed the primary structure. Only peptide bonds present in the polypeptide chain. No any other type of bonds. Okay. Okay. What is the meaning of primary structure? In the polypeptide chain, amino acid sequence. Amino acid sequence in the polypeptide chain. Even any condition, even denaturation, denaturation is the maximum adverse condition can participate for proteins, can take place for proteins. Even this condition cannot be damaged, this primary structure can't be damaged. This is any reason cannot be changed the primary structure. We can't change the sequence. Okay, we can't damage to it. And only peptide bond in primary structure, only peptide bond. They all bonds are peptide. All bonds are peptide. Example. Collagen protein. Collagen fibers. Where we can find collagen proteins? Where? in our body? Collagen fibers. Collagen fibers, where it is, where we can find it? In muscles, yes. In muscles, in our muscles, may muscles this muscles and bones connect by collagen fibers. These collagen fibers are proteins in primary structure. Primary structure proteins, they are very simple, only like a chain, polypeptide chain only. That's why they are fibers. Okay, let's move into, write down this example as well. Collagen proteins. Okay, only 3 points you need to remember about primary structure. What is the first point? What's the first point? The in the polypeptide chain, amino acid sequence we called as a primary structure. In the polypeptide chain, amino acid sequence. Okay, now in the polypeptide chain, amino acid sequence we called as primary structure, and in the polypeptide, in the primary structure, only peptide bond present in the polypeptide chain. Third point, even any condition, denaturation also cannot damage it, cannot change primary structure. This sequence cannot be changed. Okay, collagen fibers are primary structure protein. Okay, let's come to secondary structure. Secondary structure. Secondary structure. Now it is simple. Now if you understood primary structure, other structures are simple. Okay, primary structure mean this type polypeptide chain, like polypeptide chains. Okay, now these polypeptide chains, when increase the length of polypeptide chains, what happen? They convert into spin, not spin. They convert into helix structure. Helix. Okay, like this. The reason, increase the length of polypeptide chain. The polypeptide chain now it's a far long. Therefore, the length, the shape of the polypeptide chain convert into helix chain. Helix chain. Okay. Now, the other important thing, now in primary structure only peptide bonds no, between amino acids, but in secondary structure, hydrogen peptide bond plus hydrogen bond form. Peptide bond plus and hydrogen bond also form. Hydrogen bonds. That's why it's forming as a helix chain. Helix chain. Helix chain. Okay, let's read. Proteins secondary structure is a shape in which a long polypeptide chain, yes, very long polypeptide chain can exist. They have been discovered to exist two different structures. Two different structures, that is helix and plated sheet. Plated mean like this. Plated. Plated mean like a plate. It's helix, but it's called as plated. Plated or helix, whatever. The shape is that. Plated or helix. Plated or helix. They can dig a වැඩි වෙද්දී helix වෙනවා. That's the meaning. These structures form as a result of the regular folding. Yes, regular folding of the polypeptide chains backbone cause hydrogen bonding. Yes. Additionally, peptide bond another bond type is forming. This is hydrogen bond. Hydrogen bond also forming between amino acids. Okay. Okay, up to now, okay. Then what's the secondary structure? Secondary structure means due to the increase the length of polypeptide chain, the polypeptide chain convert into helix shape. Helix shape that we called as a secondary structure. What are the reason? The one reason for this helix shape, one reason is increase the length. The second reason, additionally, peptide bond, hydrogen bond form in the polypeptide chain. Okay. Now let's read the hydrogen group of each amino acid. Residue is hydrogen bonded to carbon oxygen of an adjacent turn of the helix in one of the most common way in which a polypeptide chain form all possible hydrogen bond by dividing into right. Yes. That explain the hydrogen bond is the actual main reason for these helix structures. Helix එක හදන්නේ යාළුවා. Okay, all peptide chains in structure are stretched to nearly maximum extension and then laid side by side, held together by intermolecular hydrogen bonds. The same thing explained. The hydrogen bonds are the main cause for this defaulting. Default when the main reason is hydrogen bonds. Okay, that's the main point. Okay, now what's the point in secondary structure? In secondary structure, when increase the length of the polypeptide chain, its shape take the helix structure, defolding structure due to formation of hydrogen bond addition of peptide bond. Hydrogen bond addition of peptide bond. Okay, any doubt? The example, write down example for secondary structure, keratin. Where we can find keratin? Keratin කොහෙද තියෙන්නේ? Keratin. Keratin, you already know. Yes, keratin. Yes, in our hair and nails also mainly include keratin protein. Keratin is an example. Okay, keratin shape, then අපේ hair shape and hair also when increase the length, what happen? It's folding, right? Folding, helix structure. Yes, same. Okay, primary structure protein, example collagen fibers, secondary structure keratin. Okay. Okay, it's simple. Okay, primary structure mean polypeptide amino acid sequence. Secondary structure mean uh, polypeptide chain increase the length due to hydrogen bond formation. It's defolding and make as a helix. Okay, this is the secondary structure. Okay, let's move into our tertiary structure. Tertiary structure. Tertiary structure. Tertiary structure. Tertiary. Tertiary structure. Tertiary structure. Okay. Now, tertiary structure now increase the length and additional hydrogen bonds. Now, this helix in secondary structure, this helix polypeptide chain, defolding polypeptide chain, additional different types of bonds forming. As example, now peptide bonds, hydrogen bond already available, hydrogen bond. Now, when they matured, what happened? Some ionic bond, and metal bonds, different metal bonds, different bond sites form in the polypeptide chains. Result of that, this defolding polypeptide chain, what happened? They make as a like this. They make as a 3D like a goal. 3D goal. Okay, this that we called as globular protein or tertiary structure globular protein. That we called as globular protein. Globular protein. Globular proteins mean tertiary structure is 3D shape. That we called as 3D shape. They are 2D, only chain, but it is 3D. 3D like a goal. 3D shape. They defolding and make as a goal. 3D shape. That we call as globular protein. Okay, globular protein. Protein tertiary structure represent overall folding of polypeptide chain. Yes, overall folding. Overall folding of polypeptide chain. Further folding of the secondary structure. Further folding than secondary structure. It produces two major molecule shapes, fibrous and globular. Yes, fibrous and globular. Globular is the main one, like a goal. Okay, fibrous and globular. Hydrogen bonds, disulfide leakage, they are the bonds. Van der Waals forces, electrostatic forces of attraction for main forces keep proteins in 3D structure. 3D structure. Okay, tertiary structure is a 3D structure. Okay, they are the main additional forces. Hydrogen bond already available. Disulfide linkage, that's why I told metal linkage. Disulfide linkage, Van der Waals forces, and electrostatic forces. Remember, electrostatic forces forming, and this further defolding. The result, what happened? It's make as a 3D goal, 3D structure goal. They are the tertiary structure proteins. Tertiary structure proteins. Okay, example. Most important, enzyme. All enzymes are tertiary structure proteins. Enzymes. All enzymes are tertiary structure proteins. All enzymes are tertiary structure proteins. Okay, in enzyme part, I will explain more than tertiary structure about more tertiary structure. Enzymes and albumin albumin egg protein, albumin also tertiary structure protein because it is like a globule, globule. Enzymes and albumin are the example for tertiary structure. Write down. Okay, up to now clear? Send message. Tihini? Done. Very simple. First given needs. In first one, it's just a polypeptide chain. Second one, it's make as a folding, as a helix due to hydrogen bonds. In second one, different types of bonds forming. Due to that, it's make as a further folding and make as a globule. Goal. Okay. Amina, clear? Okay, final point. Additionally, these amino acids, this stage in polypeptide chain, ferrous, magnesium like metal ions also combined for polypeptide chain. Okay, name these metal ions. See, in tertiary structure, ferrous, zinc, copper, magnesium like ferrous, zinc, copper, magnesium type, ferrous, zinc, copper, magnesium +2, copper +2, zinc plus, ferrous +2. Okay, these metal ions also combine to this bonding, linkage, and what else? Van der Waals forces, electrostatic forces. Okay, they are attractions. Due to that, metal ions also involved for this polypeptide chain. Okay, that's why it is very complex now. Tertiary structure very complex. Previous primary structure only amino acids, no any other molecule compounds. Only amino acid make as a chain. It is a primary structure. In primary structure, all proteins are very simple, but in secondary structure, we advance. In tertiary structure, it's very complicated. Lot of metal ions and lot of bonds. It's very complicated, advanced, complex. Okay, final structure, quaternary structure. Quaternary structure. Now it's simple. Quaternary structure. Quaternary structure. Okay, what happened? The secondary structure, this default polypeptide chain, not undergoing make a before further folding. That means before make the tertiary structure, what happened? Lot of secondary structure polypeptide chains combine together and make as a very strong like complex cable එකක් වගේ හැදෙනවා. Like complex cable like this. Lot of polypeptide chain that we called as a quaternary structure. Quaternary structure, it is very strong. It's as a cable that we called as a quaternary structure. Quaternary structure. Example, hemoglobin. Hemoglobin, where we can find hemoglobin? In our blood. Yes, in our blood. Hemoglobin. Hemoglobin. What is the function of hemoglobin in our blood? What they doing? Hemoglobin. What's the function of that? Hemoglobin will function. What's this? Hemoglobin. What's the function? Yes, very good. Oxygen transportation. Hemoglobin are the proteins important for oxygen transportation in our blood. In our blood. Yes, very good. Then what happened in quaternary structure? Secondary is more than, yeah, many number of secondary structure, these helix structures combined as a chain, combined as a cable, then make very complex strengthful protein that is very complex. That is very complex. The structure we called as quaternary structure. Quaternary structure. Some proteins are made up of 2 or more polypeptide chain. More actually. More than 2. 2 or more polypeptide chains known as referred to quaternary structure. Yes. Hemoglobin are the example. Hemoglobin are the example. Okay. Let's discuss about denaturation. We start next day after our paper discussion. We start enzymes, the most important next biological compound, enzymes. Next day means this Tuesday 6 p.m. Okay, final topic that we already discussed, the protein denaturation. Protein denaturation. Protein denaturation means simply change the physical state of protein permanently. Permanently change the physical state of the protein. Permanently change the physical state of the protein. A native protein is a protein found in biological system that has distinct three-dimensional structure and three-dimensional structure and biological activity. They are enzymes. When a protein is native from it's subjected to physical change such as temperature, there are 4 main factors affected for the protein denaturation. The first one, temperature. The boiling egg is denaturation by temperature. Or we can use chemical changes. We can add different acid base, powerful acid base for protein denaturation. We can change the pH. pH means acid and same, and we can use UV radiation also. UV radiation also we can use. Hydrogen bonds are disturbed. Yes, due to denaturation, hydrogen bonds break down and globular unfolded and helices uncoil and protein losses biological activities, this referred as protein denaturation. But what you need to know, මොනවද වෙන්නේ මෙයාලගේ hydrogen bond breakdown and unfold these folded structures. But remember, primary structure, the sequence, order cannot be changed. Order cannot be changed. The common example for protein denaturation is coagulation of egg. Yes, coagulation of egg, converted permanently solid. Hatch. Another example, milk curding. Next lesson we can discuss the milk curding. Okay, milk curd වෙද්දි මොකද වෙන්නේ? What happened in milk curding? What happened? Yes, what is the main carbohydrate? Last week we discussed lactose sugar. No? In next lesson we discussing lactose sugar. What happened? Lactose sugar convert into lactic acid. This is a milk curding. Milk curding can milk normal milk is fresh milk in liquids, no? Liquid form. In curd, convert into curd. What happened? It's converted into solid. Then what is the reason? That is protein denaturation. Casein protein denaturation. That the reason is protein denaturation. Okay, now lactose sugar convert into lactic acid. Lactic acid being a type of acid. Then what happened? pH value. pH value of milk getting lower. pH value getting lower. pH value is the reason for protein denaturation, right? pH change. Due to that, the casein protein, what happened? Denaturate. As a result of denaturate, the liquid casein convert into solid casein. That's why fresh milk convert into curd and yogurt also same thing. Curd and yogurt in the activation of lactic acid bacteria. Lactic acid bacteria function, lactose sugar convert into lactic acid. Understood? Or do I need to explain? The curdling process understood? Curdling we discuss again, but I got the protein denaturation. Dini? Yes. Do you know latex? Latex dhanna? What is the meaning of latex? Amina. What are the latex? Latex mean rubber වලින් ගන්න rubber කියලා කියන්නේ. They are the latex. Latex coagulation and this liquid, no, it's extract liquid from rubber plant. Then it need to convert into what? Sheets, no? Solid sheet. In the polymer lesson we can discuss, for this coagulation process we adding formic acid. Remember, okay? Formic acid we add for this coagulation process. Formic acid, what is the purpose? It's an acid. Then what happened? The pH value getting low. In low pH levels, what happened? In low pH level, this is a protein source. Rubber latex it's a protein source. This protein denaturate. That what happen? It's converted into coagulate solid form. Then we can make sheets. Understood? Fatima? Okay. Any doubt up to now? Protein part completed. Proteins completed. Okay. Okay. Protein part completed. Now we have enzymes. Biomolecule lesson, we have only enzymes, lipid, vitamins only. Very short parts. Vitamins. 70% actually completed now. Vitamins. Okay, after biomolecule lesson, we start to revise very rapidly force lesson. And we doing lot of activities of force lesson with all practicals. After that, we doing another lesson, important lesson. I will explain, I'll let you know what's our next lesson. Okay. Okay, then let's start next Tuesday evening our enzymes and our refresh paper 3. No, refresh paper 3. Complete the refresh paper 3. Okay. Work on refresh paper 3 and complete this. And yeah, now I think paper 2 you have 2 biomolecule questions. Last 2 questions from biomolecule lesson. Complete that, those questions also. Okay, that's all for today. Goodbye.